project, who's going to give us a case study of archaeological data reuse at the MAEASaM project. Thank you, Stefania.
Thank you. Good afternoon. Please confirm you see the screen and you hear me.
Yes, all good.
Rebecca?
Yes, it's all good. Thank you.
Okay, thank you. Thank you, Rebecca, and welcome, and thank you to all the participants to the workshop today. I am going to present on behalf of our team, and particular thanks to Eloise, Nock, and Ed Burnett that provided the case studies, basically, of what we're doing with data reuse in our project. I decided to offer more of a general introduction to data reuse. What is it? What is it for? And then as a premise to our thinking and offering you an overview of the current data reuse and production process within our project, and then offering some concluding remarks. I kept the talk quite generic to some extent, avoiding the use of technical terminology just to introduce some of the concepts, and then MAEASaM, our sister project, you will see as well a little bit more into the technicality, the details, and terminology that is normally used around the use, the reuse, production of digital data in archaeology using fair and clear principles. And because data reuse is in fact a term that is become quite common in the fair data discourse, but not all of us are actually actively engaged in the production of digital data on a daily basis, I thought I would just give a very brief overview of data reuse and what is it? You know, what are we talking about when we talk about data reuse? Why do we talk about it? Is this a concept that is shared by everybody or not? And so there have been a number of papers that have been published on the concept of data reuse and whether it actually comes with one unique definition. And one of the papers I'm referring to was published in 2018, and it offers a number of definitions of data reuse, but I decided to start with one that has been widely used and that was given by Zimmerman in 2008, so quite a long time ago. And initial definitions of data reuse in terms of how data is reused, particularly in a digital pipeline, but this could also apply to non-digital data, is that Zimmerman defined reuse as the use of data collected for one purpose to study a new problem. And obviously the person said, I also use the phrase secondary use, which I intend to be synonymous with the term reuse. So the concept here was very linear. It was about basically reusing data that had already been collected for one purpose to study a new problem in a different context. In reality, as we know, in terms of being archaeological practitioners and heritage practitioners, the way in which we create, reuse, even our own data, collaborate with others, go through our data over and over again, even before we are satisfied with the way in which this data is presented, means that we are constantly using and reusing our data. And so offering a one definition of reuse or deciding that reuse is a particular concept is particularly problematic. So in the paper by the Sands and others in 2018, they said that they defined as you can see in bracket, use as the use of any research resource, regardless of when it is used, the purpose, the characteristics of the data and its user. In other words, data is created in different times for different purposes with different characteristics by different users and producers. And it is a bit narrow to just look at one way of this. What the important corollary of this is also that when we use and reuse data, we should actually learn to reflect on the fact that data has been created at different points in time by different people for different purposes, used and reused over and over again, creating archives that through times shrink or expand, get transformed. And the question then is, how are we taking responsibilities as individual archaeologists, as archaeologists working within communities, as archaeologists working for particular institutions with different duties, in actually creating our own archaeology of the archaeological archive that we constantly create? How do we explain, how do we record that things change through time? We take somebody else's data, we use it for a different purpose, we manipulate it, and so on and so forth. So the question becomes not are we reusing data necessarily, but it becomes how do we engage with data reuse, and how do we allow others that will reuse the data that we have dealt with, okay, to know perhaps what we've done with it. Okay, so all the processes that are behind how data is created, recreated, remanipulated, maintained through time, and so on and so forth. And of course, this speaks to all of those aspects that we have just covered, going through very quickly a data management plan. So data has got many aspects, from accessibility to ethics, to security, and so on and so forth. And there is so much that needs to be considered that it becomes almost overwhelming. Obviously, we know that we deal nowadays, in particular when we talk about digital data, with the FAIR and CARE principles. In a very compelling way this morning, we were told that FAIR and CARE principles are not always compatible, that they not always work hand in hand. Some of the principles lean more towards the data, some of the principles lean more towards the people, which people for whom data can be fair and care at different points in time. So it is quite a complex, I think, and an overwhelming task when one starts dealing with digital data, either as a user or a producer or something in between, to do it. And for it not to become a daunting task, I think, one has to actually zoom into the particular project within which they are working, and perhaps every time become quite explicit about what this project does, what its aim is, going as far as to being very clear about who the funders of these projects are and what we commit with to our funders that have implications on how we create, originate, and also disperse the data that we're dealing with. And that's how I zoom into our project, which is coordinated by the University of Cambridge, so a very particular situation, a university in the global north that has been given funding by a charitable organization to then have this funding dispersed to other organizations in the global north and in the global south. But you can already see that the positionality is very particular. The other important aspect to cover about our project is that our overall objectives, and you will see they're very similar to our sister project's objectives, were somehow dictated by our funders. No judgment here. I think the funders have got a very compelling idea of what heritage data, the importance of heritage data, and what is the potential of creating digital heritage data. But this again is another situational piece of information that we need to have. And so we are identifying and mapping archaeological sites of different dates, using a combination of digitizing legacy records, so reusing data to some extent, creating new data via remote sensing and GIS techniques, and putting them all together in a web-based repository, which is by contract actually to be into an open source platform, which is called our Archaeological. Of course, another objective is to disseminate the information and the results. Why do we do this? We do this because our charitable organization, but ourselves as archaeologists and our partners are worried about the increasing threats that are posed to heritage. And we do realize that actually digitizing archaeological sites gives us a number of opportunities to monitor and to intervene with actions and policies in partnership with national authorities into the safeguard of archaeological sites. And I have highlighted this in particular because when we say national authorities, although obviously we are working with in-country national authorities, we do know that national authorities of heritage sometimes do, but sometimes do not consider what heritage means for the general populations of particular indigenous groups within their own countries. So as you can see, a lot of issues with use and reuse and ethics of archaeological data come in, but we've made it very clear that our main collaborators are the custodians of the data in the country where we're working, which again has got its own aspects. We obviously deal with a very complex and heterogeneous archaeological archive. A lot of the materials in the various national authorities in the countries where we're collaborating is still in an analog format. It needs to be digitized and integrated into a database. And then we have the remote sensing aspect of things, and we use satellite imagery and remote sensing to look for new archaeological sites that may have not been recorded before, or for confirm what is happening to archaeological sites that already exist. All of this data then is aggregated into an ArchIS platform, for which we have designed a database structure. And as you can see, this database can be accessed geographically or through the single records that we enter into this database. And it's got a very compelling user interface that looks much more user-friendly than the database structure that you are seeing here. Ultimately, the complexity, okay, as much as this scheme of databases looks complex, the complexity of the data, the nuances, the interventions that through time have been done on the analog or digital data sets that we are trying to aggregate into this database, it's even bigger. Okay, so how do we go about it? In our project, and I'm not going to spend too much time into this, again, it looks quite a big overall project workflow that allows us to transform our data from legacy record or from remote sensing into something that can be ingested into a common database. Okay, as you can see, we have a framework where we think about what we are doing, how we're treating our data, which different formats we are using. Ultimately, nevertheless, what we realized being a very large project, and this is what I'm going to cover very quickly this morning, is that every single individual in the project, and we expect every single archaeologist in the room today, may have or may want to have a slightly different way of engaging with the data that they are given in order to transform them and ingest them into the database. In the same way, as archaeologists, we are given a data set and we may want and wish or opt to manipulate it and treat it in a manner that is different from another person. So the way we're doing this in our project is that instead of always being obsessed necessarily with standards, with pipelines that are very fixed, with particular decisions about data, within a framework that allows us to make our data compatible, we are asking our researchers to produce this data in the manner that is more comfortable for them. Okay, and this is one step for acknowledging that we are different, and we can still produce data that are compatible, that are usable, but that can be produced in different manners by different team members in this case, but by different members of the archaeological community in general. I'll very quickly just give you two examples, one from Mali. This is the work that Eloise Nock is actually doing. And she's an individual that works obviously with another member of our team, Kevin McDonald, and also with a number of archaeologists inside and outside of Mali to produce data for the general database. And this work basically starts from documentation, from published papers and published maps. As you can see here, there is a link between the single record and the map. And she has opted, because this is comfortable for herself and for other people that she works with, to initially record legacy data in an Access database. We've just been told that Access databases are not good for long-term preservation, but that doesn't mean that people cannot use this way of entering the data into the system. She has created her own Access system. She then, of course, creates a record for each and every archaeological site that has been published. She looks for them. She georeferences maps against present day imagery. She checks if the site is still there, if it is visible, if it is not visible. She double checks that we are not assigning a number of a nearby site that looks similar. She then creates a grid, okay, and she starts surveying systematically in and around the site to look for more archaeological evidence. Again, she does this between ArcGIS and Access database, but she has also created an internal pipeline where she can transform this data to export them into a CSV format, which is a flat table, which is compatible with ArcGIS, and she can submit a dataset to ArcGIS in this manner. As you can see, it is a customized pipeline that she has created with her team. It's mainly in French, and it's compatible with our general system. So this is an example of something that is done in a different manner to everybody else in our team that shows that there is still compatibility with a general design. Moreover, what is important is that each member of our team is actually creating a documentation of how they're going about transformation and reuse of digital data, so that the person that comes in to use this data also knows how we've made it, and they have an opportunity of getting an insight on all of those single interventions that as individuals we make on this dataset. The second case study is from Sudan, and I thank Ed Barnett for preparing these slides. In Sudan, we're mainly working starting from historical maps. So Eloise starts from publications and goes to map. We start from historical maps and then we go to publications. Historical maps contain lots of useful site information, what Ed has been doing, and you can see an example here, for example, Anad graves and so on and so forth. So we know that this map has recorded graves. In order to extract data from historical map, Ed uses his own pipeline where he georeferences maps, digitized features, and then starts cross-checking information from the map with published information. And here is a breakdown of what he does. Georeferencing of historical maps using QGIS. Again, this is a different software to Eloise. This is repeated many times. Features are digitized from maps in QGIS. We then look at how they compare to where we think this feature is nowadays on a satellite image in its geometric location based on our coordinate systems. Sometimes sites are a bit far away, so we need to intervene in the reused map data to say, okay, this site has been recorded here, but in reality it is here. And this is an important operation because practitioners, when they go to the field, they need to find a site where it is today to be able to monitor it, for example. Then we go to the publications, we extract information from the publications, and we fill a centralized spreadsheet, which can be initially in Excel, but can be transformed into a CSV, where we extract what we think are useful pieces of information from the publications that can then feed into the database. So the recording of legacy data in the spreadsheets then feeds into that complex model that I showed you earlier. Extracting location information in QGIS is very important because, as I said, oftentimes legacy data were recorded with coordinates that are not necessarily precise, but we try our best to cross-use and cross-check this information. And we have a pipeline in the process that will allow the user to know that their initial position of a particular site in the historical record was here, but we transformed it and manipulated it in various manners so that it now sits where we think that site is nowadays, so that for practitioners on the ground, it becomes easier to just use the GPS and go to that site, but with the knowledge that that site had been located in the past in different places. Again, this is the workflow for extracting location from legacy data and the importance of documenting which operations we do when we change the location of sites. Okay, not only as a form for being able to find where the site is today, but also acknowledging that there are many different layers of interventions and many different layers of geographies behind an archaeological site that happened through time, through space, with the interventions of different actors. So to wrap up on what I've showed you today, this wasn't about the technical work that we do on the data, but just demonstrating that when we talk about data reuse, there are possibilities of not always being rigid about what we do with data sets. Of course, it is important then to aggregate data in an environment where it becomes easy for other people to reuse the data. But there are very many different paths that we can use to get to that particular place. One thing that I wanted to use to conclude my talk today is to alert you to a particular blog, actually, that I found very interesting. It's by Jeremy Haggett. It was published in 2019. And he reflected on what he thought were deeper challenges of reuse. We all talk about the difficulties of reuse in terms of availability of infrastructure or digital technology being developed and so on and so forth. But he went a little bit far away from this to challenge us with other issues that are at the base of reuse. Many of them, in particular, the first 4 bullets in this slide, are about the fact that even when we are dealing with digital data, and in particular when we're dealing with digital data, we should not forget that as archaeologists, we never deal with raw data. There's no raw archaeological data. It is always interpretive. It is always being produced by somebody with a particular mindset. It's always manipulated. It is incomplete and imperfect, and it has potential, but it has also a lot of unanticipated issues that come from using digital tools to produce digital data. We should reflect on what are these potentials and these limitations, but importantly, we should include information on this in our overall outcome platform, in our case, our Arches platform. And we have started interrogating ourselves on this within the project. The other issue is obviously the insertion of non-human actors in archaeological data. Nowadays, we routinely capture information on archaeology using machines. But what is the human decision behind these machines? Have we reached a time where we should actually be in a position to also articulate how we use these machine-operated data collections, including in remote sensing, the use of machine learning and artificial intelligence to again make our data more transparent when we share it with others? And lastly, one thing that has started being asked of why and how and for whom we reuse data is what is the environmental impact of archaeological data? So in our effort to document what we do with data and offer transparency about our data, what do we keep and what do we discard? We can't keep everything. The environmental impact of this would be huge, but how do we make these decisions? Do we make them individually? Do we make them collectively? Who do we incorporate and engage in the conversation about who is this data for, what is it for, and what will we do with it going forward in sharing it?
Brilliant. Thank you, Stefania, very much. Really fascinating overview and great to see the case studies in action as well. I'm going to hand over now to Junaid Abdul-Jabbar, who is the database manager for the MAEASaM project, and I'll let him present. In the meantime, if there are any questions on Stefania's presentation or Junaid,